Hi to everyone. In this video, let us discuss heat of combustion. So, some problems based on heat of combustion. First, let us come to the definition here. Combustion means burning a substance in presence of air or oxygen. So now the heat energy changes when 1 mole of a substance is completely burnt in excess amount of oxygen known as heat of combustion. So listen again here. The heat energy changes or the heat energy liberated when 1 mole of a substance is completely subjected to combustion or completely burnt in excess amount of air or oxygen is known as heat of combustion. In these two important points we have to note down here. One is that compound should be completely subjected to combustion, not incomplete combustion. The compound that should be subjected to complete combustion, not incomplete. That one thing we have to identify. And another thing, in all heat of combustion reactions, that means in all combustion reactions, heat energy is liberated. So delta H is negative for which one? A combustion reaction. These 2 points we have to remember here. So now first let us see some examples for heat of combustion here. For example, C plus O2 gives CO2 delta H value minus 393.5 kilojoules. Of course, here we have taken graphite. Now, the heat energy liberated 393.5 kilojoules. This is considered as heat of combustion of which one? Graphite. And another one more thing also here. CO2 is formed in this reaction. That too from its constituent elements present in standard state. So now the same 393.5 kilojoules will come under that minus 393.5 kilojoules come under heat of formation of CO2 also. That means this reaction indicating two heats of reactions. One is heat of combustion of graphite, another one standard heat of formation of CO2. Like that they may give the question here. Which of the following reaction indicating both heats of reactions, that is heat of formation and heat of combustion. So this is one of that examples. Okay, now for example, if the same question they have given like this, C graphite plus half O2, let us consider here. Half O2 gives CO delta H minus 110 kilojoules. Now the question is it considered as heat of combustion of graphite? Means no, because here graphite is undergone incomplete combustion, not complete combustion. So this is not come under heat of combustion of graphite. Of course it may come under heat of formation of CO, no problem. Okay, then another reaction here, N2 gas plus O2 gas will give 2NO gas. Delta H value plus 180 kilojoule. Now, here delta H value positive. Just now we have given one statement. Always delta H is negative for combustion reaction. But here we got positive. So, this is also not come under heat of combustion. So, these terms we have to remember. Complete combustion should undergo that compound. Another one, always delta H negative, means heat energy liberation takes place in any combustion reactions. So now again I repeat the definition. The heat energy liberated when 1 mole of a substance completely burnt in excess amount of air or oxygen is known as heat of combustion. Now let us see some important questions regarding heat of combustion. First question is here. Now 10 gram benzoic acid, 10 gram benzoic acid on combustion, produced produces 10 kilocalories heat energy. Now, what is its heat of combustion? What is its heat of combustion? So, heat of combustion means we have to calculate for 1 mole. Not only for heat of combustion or heat of formation, any heat of reaction is meant for 1 mole of substance only. Heat of formation means for the formation of 1 mole of that substance. Heat of combustion means that subjected 1 mole of substance should be subjected to which one? Combustion. 1 mole of the compound should be subjected to combustion. And heat of solution means 1 mole of solute should be dissolved in excess amount of solvent. And like that, any heat of reaction is regarding 1 mole only. So now here we have to calculate heat of combustion of benzoic acid means for 1 mole. Let us see formula of benzoic acid, C6H5COOH. Now let us calculate molecular weight of benzoic acid. 7 carbon atoms are there. So we have to calculate its which one here, that atomic weight, that means molecular weight here. That means 7 carbons means 12 sevens. We have to calculate 12 sevens 84. Then 6 hydrogens. 6 hydrogens means 6, and 2 oxygens means here which one? 2 into 16 means 32. So now by adding all these, what we can get here? 122. So molecular weight of benzoic acid is 122. Now let us go for this problem here. What is that? 10 grams producing 10 grams producing 10 kilocalories. Therefore, 122 grams produce how many kilocalories? So now here 122 by 10 into 10. So we can get 122 kilocalories. So this is the heat of combustion of which one? Benzoic acid. Okay, now let us see another question related to heat of combustion. What is that? See here. 4.6 gram of ethanol. 4.6 gram of ethanol on combustion gives 320 kilojoules heat energy. Now what is heat of combustion of that ethanol? What is heat of combustion of ethanol? Again here also, heat of combustion of ethanol means we have to calculate for 1 mole of ethanol. 1 mole of ethanol means let us calculate molecular weight of ethanol, C2H5OH. So now what is molecular weight of ethanol means 46 grams. So now we have to, sorry, what is its, okay, now small change, okay, you can answer like this only, 46 grams. Now here 4.6 grams producing if 320 kilojoules. Therefore, 46 grams produce how many kilojoules? That means we can get 3200 kilojoule of heat energy. For example, here instead of 4.6, if they have given 9.2 grams, now we have to solve like this here. 9.2 grams giving 360 means now 46 grams will produce how many kilojoule heat energy? Therefore, 46 divided by 92 into 10 power minus 1 into 320. 46 ones are 46 twos are, we get 1600 kilojoules. So like that we have to calculate which one, that heat of combustion. Heat of combustion of which one? Ethanol. Okay, then another question, most important question, this one is for any competitive exams. So what is that question here? Listen. Human body requires, human body requires 2370 kilocalories energy daily. Daily 2370 kilocalories energy required by human body. And heat of combustion of glucose, heat of combustion of glucose is 790 kilojoule. Sorry, 790 kilocalories you can consider here. 790 kilocalories. Now the question is, what is the amount of glucose required to consume by human body daily for this need? So now let us see here. We need 2370 kilocalories daily, and 1 mole of glucose. This is heat of combustion of glucose, means 1 mole of glucose producing 790 kilocalories. So 790 kilocalories produced by 1 mole of glucose. 1 mole of glucose means 180 gram of glucose. Therefore 2370 kilocalories will produced by how many gram of glucose? Now 2370 divided by 790 into 180. 791s are 793s are, so we get 540 grams. So this is the amount of glucose daily that human body requires for that energy. Okay, then after that, another important thing related to heat of combustion, that is calorific value. So what is another important thing means here? Calorific value. Let us see what is calorific value. Calorific value means heat of combustion of a substance per 1 gram. Heat of combustion, that means the heat energy liberated when 1 gram of a substance is subjected to combustion, that is said to be calorific value. The heat energy liberated per combustion of 1 gram of substance is known as which one? Calorific value. Now related to that one question here, what is that question means? Heat of combustion of which one? Ethane. Ethane is minus 340 kilojoules. Ethene. Ethene is minus 330 kilojoules. And ethine is minus 310 kilojoules. Now, which is the best fuel? That is the question here. Which is the best fuel means we have to determine their calorific values. To determine calorific values, what we have to do here? These heat of combustions are meant for 1 mole of each and every substance. 1 mole means the weight is equals to molecular weight. Now, by using that concept, we have to determine per 1 gram of substance. So now, let us see the molecular weights of all these three substances. Ethane, C2H6, its molecular weight is how much? 30. 12 to the 24 plus 6, 30. And ethene, its molecular weight is 28. And acetylene, its molecular weight is 20. Okay, now 12 to the 24 plus 2, 26. So these are the molecular weights. Now, calorific values we have to determine. Ethane calorific value is 340 divided by which one? 30. And ethene calorific value is how much here? 330 divided by 28, and ethane calorific value is how much here? 310 divided by 26. So like that, in which you can get the best value, highest value, that is said to be which one here? The best fuel. So this is another question related to that heat of combustion, that means related especially calorific value. So this is the topic related to which one here? Heat of combustion. And one more important thing here, heat of combustion is measured using which one here? Bomb calorimeter. By using bomb calorimeter, we can determine which one here? That by using bomb calorimeter, we can determine heat of combustion. So what is the formula we have to use here? Heat of combustion is equals to Z into theta into capital M by small m. So here Z is known as heat capacity of calorimeter with all contents, all ingredients, and theta is rise in temperature. Capital M is molecular weight of that substance, and small m is the weight of the substance taken for that combustion in bomb calorimeter. So by using this formula, we have to calculate heat of combustion. But one important thing here, as this heat of combustion is measured in which one? A bomb calorimeter. That means at a constant volume, we are measuring this, which one? Heat of combustion. So whatever the value we got by using this expression, that is indicating which one? Internal energy. Because heat content of a system at constant volume is known as which one? Internal energy. So if we want to calculate enthalpy for this reaction by using bomb calorimeter, after this calculation we have to move towards delta H equals to delta E plus delta nRT. By using this equation, let us convert this internal energy to which one? Enthalpy. That is one important thing, because bomb calorimeter is a closed vessel. That means the heat content of that system is come under internal energy but not equal to enthalpy. So using this equation, let us convert that internal energy to enthalpy. Okay, now after this, the next topic here is heat of bond, that means heat of atomization. So what is heat of atomization? Let us see here. The heat energy required to convert 1 mole of a molecule into its constituent atoms. That is known as which one? Heat of atomization. The heat energy required to convert 1 mole of a molecule into its constituent atoms. That is known as which one? Heat of atomization. So for example here, H2 when dissociated into two hydrogen atoms. So delta H value for suppose X kilocalories. Now this is known as which one? Heat of atomization of that H2 molecule. And for example for CH4, first step, CH3 plus H delta H1, CH3 gives CH2 plus H delta H2, CH2 gives CH plus H delta H3, CH gives C plus H delta H4. Therefore, average bond, average atomization or average bond dissociation energy is equals to delta H1 plus delta H2 plus delta H3 plus delta H4 by 4. Like this we have to calculate. And one important question regarding heat of atomization. Let us see what is that important question here. For example, if you consider phosphine PH3 and diphosphine is also there P2H4. Now, what is the question means here? That heat of atomization of pH3 and P2H4 they will give. So we have to calculate which one. Let us see here. Heat of atomization of pH3 is 228 kilocalories and P2H4 is 355 kilocalories. So see here, heat of atomization of pH3 is 228 kilocalories. Heat of atomization of P2H4 is 355 kilocalories. What is P dash P bond energy? We have to calculate P dash P bond energy. So how to calculate? Let us see here. First, by using this heat of atomization, we have to calculate the average bond energy of P dash H bond. Okay, now here, as it contains three pH bonds, average bond energy of pH bond equals to 228 by 3. So we have to calculate this one. 3 sevens are 21, 3 6 are 18. So 76 kilocalories. This is average bond energy of pH bond. Now let us see here. P2H4 contains 2 and 2. Here total 4 pH bonds, 1 pp bond. So total bond energy equals to 4 into P dash H bond energy plus 1 into P dash P bond energy. Here total bond energy given 355 kilocalories. 4 into pH bond means we have to multiply this 4 into 76. 4 into 76 means how much we can get? 304. So now here 304 plus energy of pp bond. Therefore energy of pp bond equals to 355 minus 304. So how much we can get? To 51 kilocalories. So like this we have to calculate which one? pp bond energy. So this is regarding which one means heat of atomization. So the heat energy required to convert 1 mole of a molecule into its constituent atoms. Okay, in our next video let us go for heat of neutralization. Okay.